While the quake that just struck appears to be the largest to have ever occurred on the southern segment of this fault line, some nearby similar or even larger magnitude earthquakes have happened in recent times. These include a magnitude 6.4 and 7.1 in 1917, a magnitude 6.4 in 1923, a magnitude 6.5 in 1995, and a magnitude 6.1 earthquake 54 kilometers away. In 2023, while all of these earthquakes occurred on separate fault lines, they occurred in the same broader fault system where west-northwest to east-southeast compression of the landscape is occasionally triggering these events. But why exactly are there so many earthquakes here? While it is well known that much of Colombia's geology and geohazards are caused by the motion geologic setting of the South American and Nazca plates, these are surprisingly not the only tectonic plate boundaries in the country. To the north, a tiny sliver of land bordering Panama is part of the Panama microplate. However, what was involved in yesterday's earthquake was also a small plate known as the North Andes Plate, which runs through a portion of the nation towards northeast. Here, the South American and North Andes plates are colliding with each other, generating compression. You might be a bit confused to learn that both of these plates are essentially moving in the same direction, that being to the west-northwest. So why is there compression in this environment? The answer is that the South American plate is moving around 33% faster than the North Andes plate, which over time does generate compression that is accommodated in part via the movement of regional fault lines. This tectonic plate boundary consists of numerous strike-slip, reverse, and thrust faults, which when combined are known as the Eastern Frontal Fault System. During the last 120 years, the overall Eastern Frontal Fault System has seen a magnitude 5 or larger earthquake strike on average every 40 months, a magnitude 6 or larger every 12 years, and a magnitude 7 or larger quake around once every 60 years. This fault system has long been known as a high-ish seismic hazard zone, so it wasn't completely unexpected to have a major earthquake there. So, how severe exactly is the damage? While it is tough to be sure, it seems that the maximum ground shaking an area experienced was equivalent to around 35% the acceleration due to gravity, which likely generated some landslides and is modeled to have created widespread liquefaction. You might note that the area of the strongest ground rock type shaking was not directly above the epicenter of the earthquake. This is because right above the epicenter is a harder rock unit, while just to its east and southeast is an alluvial plain, with sediments generally amplifying seismic waves by slowing them down as they pass through it. While no injuries or deaths have yet been reported, the U.S. Geological Survey model suggests the 6.3 earthquake has an 80% chance of having caused between 0 and 258 fatalities and $387,000 and $341 million US dollars in damage. Aftershocks are quite likely to occur, albeit at aftershocks to decreasing rate as time progresses, with the statistically largest aftershock following an earthquake averaging 1.2 magnitudes lower than the main quake. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.